Welcome back to Statistical Learning Session. Today, we'll be talking about second example for goodness of fit. It comes under probability simplex for discrete distribution. Here, today, we have slightly more important example based upon today's racial environment, racial injustice environment, and this is about social injustice. Here, we have a example of 275 jurors, which are categorized or summarized by racial group that serve the county to measure out their justice system. And the goal of this exercise is to determine whether this is actually the proportion of the jurors for each racial group is proportionate to the population of the county. That is, the county has its own proportion of each racial group, and the jurors we have is proper is similar to the proportion that we have for the county. Now, the first thing we need is a benchmark, or we need to find out what is the proportion of each racial population for a county. We know that for no county has a uniform distribution among the population. We know that for sure. Now, to get the actual data, we need to go to the census, and once we get the census, we'll get the information about proportion of each racial group in the given county. Now, for this county, we have 72% white, black is 7%, Hispanic is 12%, 9% are other racial groups. And when we add all these up, we get 100%. Can we agree that these four numbers are PMFs? They are PMFs, aren't they? What I mean is that if I randomly pick a person from the county, then I can say that 12% of the time that person is going to be a Hispanic person. If I pick a another person, I can say that 70% of the time that person is going to be a white person. Therefore, it is a probability mass functions of the particular county. Now, on other side of the equation, we have information of jurors. What he's saying is that the jurors who have served in the justice system are 275 people, and out of them, 25 is white, 26 black, 25 is Hispanic, 19 are other groups. And we need to get a proportion. And how to get proportion? Can you tell me? To get proportion, we need to divide 205 by 275 to get proportion of white people. And we want to know that if this is equal to 0.72. Similarly, we will divide 26 by 275 and we want to know whether it is close to 0.7. Here the close meaning close, that is there is no significant deviation from the 0.7 for 26 for black. That means that significant deviation mean what do you mean by significant deviation? Can you tell me? It means that any deviation that is cannot be explained by fluctuation in random sampling is called significant deviation. Now let's talk about fluctuations a little bit. When we do sampling, we have a population, and fluctuation depend upon how many people we take for sample time. Let's say there are 100 people, and we take 5 people at a time and we calculate some numbers, there will be more deviation than if we take 90 people out of 100 and calculate some numbers. That means when we take 90 people out of 100 people, it will be more closer to the truth than if you take 5 out of 100 people, because some it may go up, some it may be less than the actual value. So that's the fluctuations is in random sampling. In it, let me quickly summarize what we learned today. We learned about probability simplex of this discrete distribution, and this is for PMF. The use case was county justice system, where it had 275 jurors in pass, and we want to know whether the distribution of jurors we have is closely matches to the distribution of the racial people in a given county. And for that, we took the benchmark using census data for a county, and we calculated the proportion of the jurors dividing the population of each racial group by total group. And we want to compare this whether two numbers are close and it doesn't significantly deviate. So that's all for today. I'll see you next learning session. Thank you so much.